Students, in our last video, we talked about, or I talked about rather, the series and sequences where we used sigma notation. I want to start with a little review or warm-up of that. And I'm going to use this one right here. Notice they use K for one thing, but I take the lower index and I plug that in, and 4 times 3 is 12, minus 2 will give me 10. Then I plug the upper index in, and that'll be 24 minus 2 is 22. Add those together and divide by 2, so I'm finding the x-bar. So I know the x-bar, or the mean, is equal to 16. Now I take how many terms, because remember, it's x-bar times the number of terms. I take 8 minus 4, which is 4, must add 1, and it's 5. So I got to take 16 times 5, which, by the way, is the same thing as if I half this one and double this one, it's 80. So I don't know if you've ever do that kind of mental math, but that is the answer. One thing I struggle with every year, and I've never found a good way to explain it, I just have to show it, which is typical for math, right? But it bothers me that I can't explain it, is why I add the 1. See, if I start with a 10, let me go ahead and write this sequence out for you. If I start with a 10, it increases by 3 each time. It's 10, 13, 16, 19, 22, because this is the fourth term, right? And this is the fifth term. This is number 6, number 7, and number 8. So notice that to go from the fourth term to the 8th term, indeed, is 5 terms. But if you take 8 minus 4, it's 4. So I know in my head it's because it includes those points, but it's hard for me to explain that. But that's why I add 1 each time. Going on, you've seen these screens. I said in my last video I was going to do this. I want to hold on to this because there are some really cool patterns with numbers that makes this screen deserve its own video. Yes, that's what you want, another video, yes? So after teaching Friday, I was more committed to doing videos than ever. And I'll explain, well, I won't explain. On this, you're going to be asked, they're going to give you these graphs, and they're discrete graphs, meaning they're non-continuous. Notice the points are not connected. And they're going to ask you a rule for the sequence. All you have to do is pretend like they are connected and that it's a line and give them that equation. So notice here, my slope is 1. I'm doing number 21. So I know it's y is equal to x. And if I extend my line to the y-intercept, it's minus 2, which is kind of like a cheating way to do it. But hey, you know, it's an easy graph. That's what they get for giving me something so easy. But remember, this is function form. They may ask you to put it in a sub n form, which is a of n is equal to n minus 2, not a big deal. Or if they put it recursive, I can't spell recursive, that would be term at the first position is equal to 1, and the t of n is equal to t of n minus 1, and they're adding 1 each time. So here's my recursive, here's my function. I can't remember what this is called. Is that explicit? I can't remember. Alright, so let's move on because we're timed. On this one, I can see the slope is equal to negative 2, but I'm not sure what the y-intercept. So I'm going to use point slope form, and I want you to know this. You must know this. Please learn this if you haven't already. This is from last year, and I know that Ms. Scruggs and I know that Ms. Hawkins taught this because we've talked about it. So I'm going to use this point 1, 1 because look, it's 1, 1, right? So remember, if it's y minus y sub 1, means you're going to sub a y in there. M times x minus x sub 1, you're going to sub an x there. So I carry down to y minus 1, because I'm using that coordinate 1, 1, negative 2, x minus 1. And I need only solve for y, which means isolate the y. Begin by negative 2x plus 2, and I need to add 1 to both sides. I get y is negative 2x plus 3. Using Brooklyn's first term shortcut, negative 2 plus 3 is positive 1, and that's right, so I know that's good. let's do this one. I'm going to pick out 2 points. Now remember, if it's a linear equation, it doesn't matter which points you pull out. They don't have to be next to each other, any 2 points, because the rate of change is constant, and so you're going to get the right equation. I'm going to use 1, and instead of using 4.5, I prefer fractions. 1, 9/2, and then 3 and 7/2. So let's take my changes in y first. I like to do it the same way each time. 9/2 minus 7/2 is 2/2, which is 1. And then 1 minus 3 is -2. So my slope is -1/2. Now, to find my point, I think I want to use 4/3. I'm not going to use fractions when I use point slope, am I? Y minus 3 is equal to -1/2 x minus 4. So I'm going to take -1/2 x. I'm distributing the 1/2. And instead of saying 1/2 times 4, when I have a fraction, I like to use of instead of times. What's 1/2 of 4? Well, it's 2, and it's going to be positive 2 because it's negative times negative. Now I need only to add 3 to both sides, and y equals -1/2 x plus 5. So I hope you're good at these. And that's all you do to find the rule for the sequence. Now to graph the sequence, remember this is the output, and I'm going to give you these where I give you just numbers and I say graph it. And if you come up to me and say, I don't know how to do that, I'm going to assume you didn't watch the video. So remember that this is the output, and your input is assumed to be 1, 2, 3, 4, 5. They just start with the positive integers. So I'm going to do this one in blue. When x is 1, y is 1. When x is 2, y is 2. X is 3, y is 3. X is 4, y is 4. X is 5, y is 5. And I'm not going to connect these, nor am I going to extend these because they're finite. Yes? Yes. Okay, I'm going to do this one in green. Remember, this means when x is 1, y is 2. And when x is 2, y is 4. And when x is 3, y is 6. And when x is 4, y is 8. And when x is 5, y is 10. So there's that point. I'm going to do the other one in red. How nice to have all these colors, yes? And be able to interchange between them so easily. So when x is 1, y is 1/2. When x is 2, y is 1. And when x is 3, y is 1.5. And when x is 4, y is 2. And voila. So there is my graph. Again, I don't connect. I do not extend it. I don't make it a line. It is discrete points, and they are what? Begins with F, ends in inite. Yes, finite. Okay, then you're going to get these where I just give you this sequence. By the way, these are infinite. You can tell by the ellipse, yes? And I'm going to find the rule for the nth term. I prefer that you just give me the function. So let's do this in red. Notice that they're adding 4 every time. So that is my what? Begins in S, ends in lope. Yep, it's slope. So y is equal to 4x. And if there was a 0 term, because that's my y-intercept, when you're looking at that y-axis, x is 0 for that entire length of that thing. So when x is 0, what is the y? Just subtract 4 and you get to it, and it's plus 15. Look at this one. What is the slope? Y is equal to 2x, and if there was one right here, what would it be? It would be 3. And let's use the Brooklyn method to check that point. 2 plus 3 is 5, and yes, the first point is 5. Now this one, obviously, it's a decreasing function, which means a negative graph. I get negative x plus 5. But wait, there's more. They asked me for a sub 15. That simply means x equals 15. The term position, what's the 15th term? Well, you just plug 15 in right there. 4 times 15 is 60, plus 15 is 75. So you would say a sub 15 is equal to 75. See how I express that? A sub 15? Good deal. All right, on this one, I do the same one. I do the same thing. I put 15 in, I get 33. So what's wrong with me? A15 equals 33. If you want to do this, 1533, that's cool. Same thing here, 1575. Did I just say that's cool? It's pathetic. Someone my age using cool. So again, I put negative 15 plus 5, I get negative 10. So A sub 15 is equal to negative 10. Or you can say 15 negative 10. Please understand, these two are synonymous. They mean the same stinking thing. Okay, this is the one that when I show this in class, people thrash their head about, scream out, groan, sigh. It drives me crazy when you guys do that. Stop doing that to me. I'm an old woman. So, remember what I said that meant. That means the 20th position. This is how you interpret that or translate that to something you understand. A sub 20 equals 240 is the same thing as saying 20, 240. It's the coordinate, x is 20, y is 240. On the next one, this is 15, 170. See, that's my x, that's my y. That's all that means. That's number 11. On number 12, let's do that one. The x is what? Say it with me. 6, 13. And then the x is what? 14, 25. Okay, don't leave me hanging here. You say it with me. What's the x on number 13? It's 9. And y is negative 14. Good job. And then it's what? 15, negative 20. Oh, I sound like, I think I said it earlier. I'm not sure. I thought it earlier that I feel like one of those exercise instructors on the video where they're exercising, looking at a camera, and they're saying to those of us watching the exercise video, "You're doing a great job. There you go. Good job." And you're thinking, they do not know that I am sitting here eating popcorn instead of doing the exercises, and they're saying, "Good job." Okay, so here's the next one, 5, negative 32. And number 15 would be what? 16, 6, and then 20 and 7. And on number 16, it's yuck. 6, oop, I just messed up. I messed up. As if I never do. We know that I do a lot. 7, 6/7, and then it's 9, 2/3. Okay, those are the coordinates. I want you to practice. Please practice. I want you to pause this. Try these problems. See if you can get all 6 right. You're trying to do at least, at the most spend 2 minutes per problem. At the most. Hopefully you can do 1 per minute, which is optimal. So, and get them all correct. So practice for your next what? Your exit card. This is great practice for your exit card. And I'm going to show you the next screen. So pause it so you can do them. And then the next screen has your answers. Nope, it doesn't. There they are. Those are the equations. If you got every single one right, bravo, you brilliant child. I'm going to end this video now because I'm closing on 15 minutes. We're going to do word problems and patterns next. Take care.